यहाँ पर आपको एजुकेशन, एक्सप्लेनेशन, टॉप 10 क्वेश्चंस, इंपॉर्टेंट क्वेश्चंस और एग्जाम्स के मुताबिक न्यू अपडेट्स मिलती रहेंगी।
My dear students, welcome back to our channel. In this video, I will be explaining the MBA third semester subject Business Analytics as prescribed by Usmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is Predictive Analytics. Predictive Analytics is a part of business analytics that uses past and present data to predict future outcomes. It helps businesses answer questions like what will happen next and how much will we sell in the future. Predictive Analytics uses techniques such as trend analysis, regression, forecasting, and data mining to make predictions. It does not guess randomly, instead, it studies patterns in data and uses them to predict future results. Example: a mobile company studies the last 5 years' sales data and predicts how many phones it will sell next year. If sales are increasing every year, the company plans higher production. Importance: helps in future planning, reduces risk and uncertainty, supports better business decisions. Remember, predictive analytics is equal to past data plus patterns is equal to future prediction. It helps businesses prepare for the future instead of reacting late. Next important short question is 2 trend lines. A trend line is a straight or curved line drawn on a graph to show the general direction of data over a period of time. It helps in understanding whether values are increasing, decreasing, or remaining stable. Trend lines are widely used in business analytics for forecasting and decision-making. There are mainly 3 types of trends. Upward trend, values increase over time. Downward trend, values decrease over time. Horizontal trend, values remain almost the same. Example: a company draws a trend line on a graph showing monthly sales. If the line moves upward, it shows that sales are growing every month. The manager can then plan to increase production. Importance: shows overall data movement clearly. Helps in future prediction. Easy to understand and interpret. Remember, trend line is equal to direction of change over time. It turns numbers into a clear story about the future. Next important short question is 3. Predictive modeling. Predictive modeling is a technique in business analytics used to predict future outcomes by analyzing past and present data. It uses mathematical models, statistics, and machine learning to find patterns in data and make forecasts. In simple words, predictive modeling answers the question: what is likely to happen next? Example: a bank studies past data of loan customers such as income, age, and repayment history. Using predictive modeling, the bank can predict whether a new customer will repay the loan on time or not. This helps the bank reduce risk. Uses of predictive modeling: forecasting sales and demand, identifying risky customers, improving business decisions. Benefits: helps in planning for the future, reduces uncertainty and risk, saves time and cost. Easy to remember. Past data plus patterns is equal to future prediction. Predictive modeling helps businesses prepare today for tomorrow. Next important short question is 4. Forecasting techniques. Forecasting techniques are methods used in business analytics to predict future values like sales, demand, profit, or population based on past data. In simple words, forecasting helps businesses look into the future and plan better. There are mainly two types of forecasting techniques. 1. Qualitative techniques based on expert opinion and experience. Example, a manager estimates future sales based on market experience. 2. Quantitative techniques based on numerical data and mathematical models, such as trend analysis, moving averages, and regression. Example, a retail shop studies last 5 years' sales data and uses trend analysis to forecast sales for the next year. This helps in planning inventory and avoiding losses. Importance of forecasting. Helps in decision making. Reduces business risk. Improves planning and budgeting. Easy to remember. Past data analysis, future plan. Forecasting techniques help businesses prepare today for tomorrow's demand. Next important short question is 5. Data mining. Data mining is a process of discovering useful patterns, relationships, and hidden information from large amounts of data. In simple words, it means digging data to find valuable knowledge, just like mining gold from the earth. Data mining is widely used in business analytics to support smart decisions. Example, an online shopping company analyzes customer data using data mining. It finds that customers who buy mobile phones often buy earphones together. Based on this, the company creates combo offers to increase sales. Common uses of data mining. Understanding customer behavior. Improving sales and marketing. Detecting fraud. Benefits. Saves time and cost. Improves business performance. Helps in better decision making. Easy to remember. Big data, hidden patterns, smart decisions. Data mining turns raw data into valuable business insights. Next important short question is 6. Association. Association is a data mining technique used to find relationships or patterns between items in a dataset. In simple words, it tells us which items often occur together. Businesses use it to understand customer behavior and improve sales. Example, a supermarket uses association analysis and finds that customers who buy bread also often buy butter. Using this information, the store places bread and butter together or creates combo offers to increase sales. Key points about association. Helps discover hidden patterns in data. Commonly used in retail, e-commerce, and marketing. Supports cross-selling and promotions. Importance. Improves marketing strategy. Increases revenue by identifying product combinations. Helps in inventory planning. Easy to remember. Association is equal to if A is bought, B is likely bought too. Association analysis helps businesses understand what customers want together and boost sales effectively. Next important short question is 7. Cause-effect modeling. Cause-effect modeling is a technique in business analytics used to identify the relationship between a cause and its effect. In simple words, it helps businesses understand why something happens and how one factor impacts another. Example, a company notices that sales dropped last month. Using cause-effect modeling, they analyze factors like price increase, advertisement reduction, or competitor promotions to find the reason behind the decline. This helps them take corrective action. Key points. Helps in finding reasons behind outcomes. Supports decision-making and problem-solving. Can be used in marketing, production, finance, and operations. Importance. Predicts outcomes based on changes in causes. Helps reduce risks and losses. Improves business planning. Easy to remember. Cause-effect action. Cause-effect modeling helps businesses understand problems clearly, take action, and improve results. Next, Unit 3. Long questions. First important long question is 1. Regression analysis, linear and multiple. Regression analysis is a statistical method in business analytics that helps businesses understand the relationship between variables. It is used to predict one variable, dependent, based on one or more other variables, independent. Regression is very useful for forecasting, planning, and decision-making. 1. Linear regression. Linear regression studies the relationship between one independent variable, x, and one dependent variable, y. It assumes that the relationship is linear, meaning it can be shown as a straight line on a graph. Equation. Y is equal to a plus bx. Y is equal to dependent variable, what we want to predict. X is equal to independent variable, what affects y. A is equal to intercept, value of y when x is equal to 0. B is equal to slope, how much y changes for a unit change in x. Example. A company wants to predict sales, y, based on advertising cost, x. Using linear regression, they find that higher advertising leads to higher sales. Use. Forecasting sales, revenue, demand. Understanding how one factor affects another. 2. Multiple regression. Multiple regression studies the relationship between one dependent variable, y, and two or more independent variables, x1, x2, x3. It helps in analyzing complex real-life scenarios where many factors affect the outcome. Equation. Y is equal to a plus b1 x1 plus b2 x2 plus b3 x3 plus. Example. A retail store wants to predict monthly sales, y, based on advertising, x1, price of products, x2, customer income, x3. Multiple regression helps understand how all these factors together influence sales. Use. Business forecasting, risk analysis, resource planning. Importance of regression analysis. Helps in data-driven decision-making. Predicts future trends accurately. Identifies key factors affecting outcomes. Reduces uncertainty and risk. Easy to remember. Linear regression is equal to one factor prediction. Multiple regression is equal to many factors prediction. Regression analysis turns data into insights, helping businesses plan, predict, and grow confidently. Next important long question is 2 approaches in data mining. Data mining is the process of finding useful patterns, relationships, and knowledge from large datasets. To make this process effective, businesses use different approaches in data mining. These approaches help in analyzing, summarizing, and predicting data trends. 1. Data exploration. Data exploration is the first step in data mining. It involves examining data to understand its structure, quality, and characteristics. This includes analyzing averages, minimum and maximum values, distributions, and visualizations like charts and graphs. Example. A retail store explores customer data to see average purchase value, age distribution, and frequently bought items. This helps identify trends before deeper analysis. Importance. Detects missing or inconsistent data. Helps in understanding patterns. Guides the next steps in analysis. 2. Data reduction. Data reduction is about reducing the size of the data without losing important information. This makes analysis faster and easier. Techniques include removing unnecessary columns, summarizing data, or selecting only important features. Example: from 100 columns of customer data, the analyst selects only 10 important columns like age, income, and purchase frequency for predicting buying behavior. Importance: speeds up analysis, focuses on important factors, saves storage and computing resources. 3. Data transformation. Data transformation converts raw data into a usable format for analysis. This includes normalization, encoding, and aggregating data. Example: customer ages are grouped into categories like 18 to 25, 26 to 35, etc. To make analysis easier. 4. Model building and analysis. After preparing data, analysts build models using techniques like classification, regression, clustering, and association to find insights and make predictions. Example: a bank predicts which customers are likely to repay loans and which may default. Importance of approaches in data mining. Makes analysis organized and efficient. Helps in discovering hidden patterns. Supports data-driven business decisions. Easy to remember. Data exploration, data reduction, transformation, model building, insights. These approaches turn raw data into valuable business knowledge, helping companies plan, predict, and improve performance. Next important long question is 3. Data exploration and reduction. Data exploration and reduction are key steps in business analytics and data mining. They help businesses understand large datasets, simplify them, and focus on important information for analysis and decision-making. 1. Data exploration. Data exploration is the process of examining and understanding data to identify patterns, trends, errors, or missing values. It helps analysts decide how to prepare the data for further analysis. Techniques used in data exploration. Summary statistics: mean, median, mode, min, max. Visualizations: bar charts, line charts, histograms, and scatter plots. Detecting anomalies, missing data, outliers, or inconsistent entries. Example: a supermarket explores customer purchase data to find the average spending, age group of buyers, and frequently bought products. This exploration helps identify trends before deeper analysis. Importance: understands the structure and quality of data. Detects errors or missing information. Helps in finding patterns and insights. 2. Data reduction. Data reduction is the process of reducing the volume of data while keeping important information. Large datasets can be overwhelming, and data reduction makes analysis faster, easier, and more accurate. Techniques used in data reduction. Attribute feature selection, choosing only relevant columns. Aggregation, combining data into summaries. Sampling, using a smaller, representative dataset. Dimensionality reduction, reducing variables while preserving relationships. Example: from 100 columns of customer data, an analyst selects only age, income, purchase frequency, and product preference to predict buying behavior. This reduces complexity and saves time. Importance: speeds up analysis. Focuses on relevant information. Reduces storage and computing costs. Easy to remember. Data exploration is equal to understand data. Data reduction is equal to simplify data. Together, exploration and reduction prepare large datasets for accurate analysis, helping businesses discover insights, predict trends, and make smart decisions. Tip: Think of it as exploring a jungle to see what's there, then clearing unnecessary trees to focus on the path. Next important long question is 4. Data mining and business intelligence. Data mining and business intelligence. Data mining and business intelligence (BI) are two important tools in business analytics that help companies make better decisions. Although they are related, they focus on different aspects of data. 1. Business intelligence (BI). Business intelligence is about collecting, organizing, and analyzing past and current data to understand business performance. It helps managers answer what happened and how are we doing. Example: a retail company uses BI to see last year's sales, which products sold most, and which stores performed better. This helps managers understand current performance and trends. Features of BI: dashboards and reports, monitoring key performance indicators (KPIs), historical data analysis. 2. Data mining. Data mining goes a step further. It analyzes large datasets to discover hidden patterns, relationships, and future trends. It helps answer why did it happen and what might happen next. Example: using data mining, the same retail company finds that customers who buy bread also buy butter and predicts future demand for combo offers. Techniques used in data mining: classification, association, regression, clustering, cause-effect modeling. 3. Differences between data mining and BI. Feature business intelligence data mining. Focus past and present data, hidden patterns, and future predictions. Purpose reporting and monitoring, discovering insights and forecasting. Example: last year's sales report predicting next month's sales trend. Importance: BI helps managers understand performance and monitor business. Data mining helps predict trends, reduce risks, and make smart decisions. Together, they make businesses data-driven, efficient, and competitive. Easy to remember. BI is equal to what happened. Data mining is equal to why it happened and what will happen. Think of BI as a rearview mirror showing the past, and data mining as a GPS guiding the future. This combination helps businesses plan, predict, and succeed in a competitive market. Next important long question is 5. Data mining for business, classification. Classification is a key technique in data mining that helps businesses organize data into categories or classes based on past information. In simple words, it predicts which category a new data item belongs to. Classification is widely used in business analytics for decision-making, marketing, risk management, and customer management. How classification works: 1. Collect historical data with known outcomes. 2. Build a model using this data. 3. Apply the model to new data to classify it into categories. Example: a bank wants to know which customers are likely to repay loans and which might default. Using historical data like income, credit score, employment, and past loans, a classification model divides customers into good borrowers, risky borrowers. Another example is in retail, where customers are classified as loyal, occasional, or one-time buyers based on their buying patterns. Importance of classification in business: helps predict customer behavior, supports targeted marketing campaigns, reduces financial risk, improves resource allocation and decision-making. Techniques used in classification: decision trees, logistic regression, naive Bayes, support vector machines (SVM), Key points. Input data. Historical records with known outcomes. Output, predicted category for new data. Goal, accurate prediction to help decision-making. Example in marketing. An e-commerce company classifies customers as high, medium, or low spenders. High spenders get special offers, medium spenders get discounts, and low spenders get targeted advertisements to encourage purchases. Easy to remember. Classification is equal to put new data into the right category. Think of it like a school teacher dividing students into classes based on their marks. Similarly, businesses use classification to group customers, products, or risks and make smarter, data-driven decisions. Classification is a powerful tool in data mining that helps businesses predict, organize, and act strategically.